In this video, I'm going to explain you how to find the moment and product of inertia of a rectangular parallelopiped. So a parallelopiped is similar as a cuboid. So we are going to find the moment of inertia and the product of inertia of a cuboid. So students, please do by yourself how to find the moment of inertia and product of inertia of a cube. So you try by yourself how to find the moment of inertia and product of inertia of a cube in the similar manner as I will be going to do for a parallelopiped or cuboid. So in this case, I'm taking the length of a parallelopiped as 2a and breadth as 2b and the height as 2c. So the mass of this, so we are trying to find the moment of inertia about the center of a parallelopiped. So we are taking the axis at the center of a parallelopiped, and we are taking the mass of this parallelopiped is nothing but capital M. So I'll consider one small element here. So this small element is nothing but it is a parallelopiped as well as, so or we can say it is a cuboid of length delta x, breadth delta y and height delta z. So I'll consider one point here. So the coordinate of this point P is nothing but it is x comma y comma z, and the mass of this particle is m. So since the object is lying in 3 dimensions, so we try to find the mass per unit volume. So like last time I have explained you already, for a rectangle, since the rectangle is lying in a 2 dimension, we are going to find the mass per unit area, and in case of a rod we find the mass per unit length. So in this case, since it is lying in 3 dimension, we are going to find the mass per unit volume. So here we are going to find what will be the mass per unit volume. So mass per unit volume is nothing but the total mass divided by the volume. So the total mass of this parallelopiped is nothing but capital M, and volume is 2a into 2b into 2c. So that's why we get here m by 8abc. So we'll try to find what will be the mass. We'll try to find what will be the mass of this element, peak element here. So the mass of this element is nothing but mass of a single point. Mass of a single point is small m, and the volume of this cuboid, that is nothing but delta x into delta y into delta z. So mass of this element is nothing but small m, that is equal to mass per unit volume. So we have here m by 8abc, which is into delta x into delta y into delta z. So that is the mass of the element. Now we are trying to find the distance of p from the x-axis is nothing but square root of y square plus z square, and distance of p from the y-axis is nothing but square root of z square plus x square. Same way, the distance of point p from the z-axis is nothing but square root of x square plus y square. So we are going to find what will be the moment of inertia about the x-axis, which is denoted by a. So a is nothing but the moment of inertia about the x-axis. So this is given by summation delta m y square plus z square. So since this line, we try to the limit will depend upon the x coordinate, y coordinate and z coordinate. So we'll try to integrate along the x-axis, y-axis and z-axis. So we will have a triple integration here. So with the triple integration, so the triple integration will be given here. So we have the, in place of delta m is nothing but delta m is we have calculated here, so that is m by 8abc. So we get here m by 8abc, and here in place of delta x we are writing here dx, in place of delta y we are writing dy, and in place of delta z we are writing dz, and this is the distance y square plus z square. So we are writing here y square plus z square. Now how to find the limit of this, since I have already explained you that the length of this rectangle is 2a, the length of this cuboid is 2a, and the breadth is 2b, and the height is 2c. But since the axis is lying at the center, so we'll take the limit as minus a to a for the x, okay, and minus b to b for the y, and minus c to c for the z. So here we can see that this m8abc is nothing but it is a constant. So it will come out of the integration. We try to integrate this with respect to x. So when you integrate this with respect to x, we get here y squared x plus z squared x minus a to a dy dz. So we put the upper limit and lower limit. So when we put the upper limit and lower limit, we get something this way. So that is nothing but 2y squared a plus 2z squared a. So we try to take common to a. So when you take common to a, we get here this 2a m by 8 abc into 2a, and minus c to c minus b to b y squared plus z squared dy by dz, dz. So 2a and this will be cancelled, so we get here m by 4bc minus c. Then we try to integrate this with respect to y. So if we integrate this with respect to y, we get here y cubed by 3 plus z square y, and we have put the limit minus b to b. So after putting this limit here, so we get if we put the limit here in this way, so we get nothing but this. Okay, so that is nothing but 2b cubed by 3 plus 2b z square. So we'll try to take common from here 2b, so we take common here 2b, and we are left with b squared by 3 z squared dz. So we cancel this. Okay, we cancel this, we get m by 2c. So we try to integrate this quantity with respect to z. So if we integrate this quantity with respect to z, we get here b squared 3z plus z cubed by 3. So we get here z cubed. So put the upper limit and lower limit, and after that you try to simplify this. After simplification, you get nothing but 1 by 3 m b squared plus c squared. Okay, so that is the moment of inertia about the x-axis. Then we try to find what will be the moment of inertia about the y-axis. So moment of inertia about the y-axis is summation delta m z squared plus x squared. So the limit is almost exactly the same. Then we know that moment of inertia is nothing but mass into perpendicular distance, square of the perpendicular distance. So when we look here, I have already written the distance of point P from OY is nothing but square root of z square plus x square. So if I square this one, we get nothing but z square plus x square. So here mass of the strip, or mass of the element is nothing but m by 8 abc dx dy dz, and the distance is nothing but distance square is nothing but z square plus x square. Okay, so in that way this is a constant, so we try to this is a constant, so it will not it can come out of the integration, so it is coming out from the integration. We get m 8 abc, and we try to integrate this quantity with respect to x. So if we integrate this quantity with respect to x, we get here z squared x plus x cubed by 3 minus 8 to 8 dy by dy dz. So after putting this limit, we get here 2az square plus 2a cubed by 3. So you take 2a common, so after that you cancel, and we try to integrate these quantities with respect to y. So if we integrate this quantity with respect to y, we get here nothing but z square y plus a square by 3y, and we'll put the upper limit and lower limit dz. So in that way we try to you put the upper limit and lower limit. So after putting this, we get this much. So we try to take common 2b, so we take common 2b, and we try to integrate this quantity with respect to z. So if we integrate with respect to z, we get this. Then you put the upper limit and lower limit, and after simplifying this, we get the moment of inertia about the y-axis to be nothing but m by 3 c square plus a square. So c is equal to, c is nothing but the moment of inertia about the z-axis. So we have this, so the limit will be almost exactly the same. So we have also seen here, you've seen that the distance of p from the OZ axis is nothing but it is square root of x squared plus y squared. So if I square this, we get nothing but x squared plus y squared. So the distance of the point from the OZ axis is nothing but it is x squared plus y squared. And we know that moment of inertia is mass into square of the perpendicular distance. So here the mass is m by 8 abc dx dy dz, and the distance square is nothing but x squared plus y squared. M by 8 abc is a constant. It will come out of the integration, so we have here m by 8 abc minus c to c minus b to b. Then we try to integrate this quantity. We are trying to integrate with respect to x. So if we integrate this quantity with respect to x, we get nothing but x cubed by 3 plus y squared x minus 8 to 8 dy dz. You put this limit here, so after putting limit here, we get this. So from here we can see that we can take common to a, so you take common to a. So in the same way, you try to integrate this with respect to y. So if you integrate this quantity with respect to y, we get this. So from here we get after that you apply the limit. So after putting the limit, we get something like this. Okay, so from here we can see that we can take common to b. So you take common to b, so we are left with this. So you integrate this quantity with respect to z. So when you integrate this quantity with respect to z, we get nothing but we are trying to integrate this quantity. So this is constant, it will come out, so we integrate dz. So dz is nothing but z, and we put the upper limit and lower limit. So when you put the upper limit and lower limit, we get 2c. So with 2c we cancel, and we get the moment of inertia about the z-axis is nothing but 1 by 3 m a square plus b square. So that is the moment of inertia about the z-axis. So now we are going to find the product of inertia d. So d is nothing but summation delta m y z. So the limit is almost the same, and we have that delta m is nothing but m8 abc dx dy dz, and the distance is yz. So yz is given here. So m by 8 abc is a constant if you come out of the integration, and we try to integrate this with respect to x. So if we integrate this with respect to x, we get this much. So minus a to a. Okay, to minus a to a, put these limits. If you put this limit, we get here 2a yz dy dz. So after that, what 2a we can take common. So after that, we take common here, so we get here yz. So we try to integrate yz with respect to dy. So z is a constant, we integrate only y. So if we integrate y, we get y squared by 2. So we get y squared by 2 z, and the limit is minus b to b dz. So you try to put this limit, upper limit and lower limit. So when you put the upper limit and lower limit, we get somewhat like this. So here we can see that minus b whole thing squared is nothing but b squared. So we get here b squared by 2z minus b squared by 2z. So this and this will be minus. If you minus these two quantity, we get 0. 0 into anything, 0 into dz is 0. So this part, the whole thing will get nothing but 0. So the product of inertia d is 0. So we are going to find about the product of inertia e. So when you try to find the product of inertia e, we have the formula summation delta m zx. So the limit is same as before what I have explained you. So we have here m8 abc zx dx dy dz. So we'll try to put this limit. So we'll try to integrate the first quantity with respect to x. So if we integrate the first quantity with respect to x, z is a constant, we'll try to integrate x. So with respect to x, so we get x squared by 2. X squared by 2, we put the upper limit and lower limit. So when you put the upper limit and lower limit, we get this. So this quantity minus this quantity is 0. So 0 into this whole thing will be 0. So we get the product of inertia e to be 0. So similar way, we try to find the product of inertia is equal to summation delta m xy, and that is equal to minus c to c minus b to b minus a to a, and the delta m is nothing but m8 abc xy dx dy dz m8 abc. So we try to integrate xy with respect to x. So if we integrate xy with respect to x, we get x squared by 2 minus a to a. Then we put the limit, upper limit and lower limit. If we put the upper limit and lower limit, we get nothing but this. So you can see that if we minus this quantity with this quantity, we get 0. So if anything is 0, if we take the integration also, we get 0. So the product of inertia f is also zeros. So we got all the moment of inertia and the product of inertia for a parallelopiped when the axis is passing through its center. So this question I'm giving you as an assignment, so you just do it. So here we are trying to show you have to find the moment of inertia and the product of inertia of a rectangular parallelopiped about an axis through its corner. So when you take through its corner, everything will be same except only the limit will change. Here I have taken the limit as minus a to a minus b to b minus c to c. In this question, you have to take the limit from 0 to 2a, 0 to 2b, 0 to 2c, and proceed in the similar manner, and you get the moment of inertia and product of inertia. Thank you.